as you can to understand how the technology impacts is going to happen in the near future. Normally, I don't use technology of something with encounters in between. This happens because currently we are too optimistic about the situation at the moment, and we're not aware of that how the technology itself is going to be sufficient enough, especially when we lack of technical infrastructures. We constantly experiencing the security problem for our mainstream mainnets, and for the most popular projects, Ethereum, this can be easily jammed by CryptoKitties. So personally, for me, I have no idea how the future blockchain, what it will be, what it will look like. And that's something that I want to share in terms of the, I don't have time for security, but I do have time for scalability and for dev-friendly. So first I will go for scalability. It's called contract scalability. The reason why I use contract in front of scalability is that for UTXO, it's not that hard. These are just transactions. For transactions, you can do the parallel execution on the transactions. So order, sometimes it matters with double spending, but most of the time, order doesn't matter. And, sorry. For contract scalability, the main problem is the dependency issues. For example, like if I want to send you 100 of some token, like a Ruff token, well, currently Ruff is in ERC20. Let's say I want to send you 100 some sort of the ERC20 tokens, but before that, we have a prerequisite that is to unlock the balance. Otherwise, you cannot do the transaction. So those two operations, they cannot be done within different process. So when you're trying to merge them, they have a dependency issue. So one, the unlock contract has to happen before you send any transactions. And that applies on the atomic operations too. For atomic operations, it means that, let's say I want to transfer 100 some sort of tokens to you. While on the Ethereum network, it's not like the Quantum or Bitcoins. The Ethereum is using an account. So they check the balances for both accounts, and then they modify the balance on both accounts. So it's going to be neither. It's going to be a both or neither. It's not an either or. It's a both or neither. Both our accounts gets modified, or neither of us gets changed. All right, that's the atomic operations. But those problems can be done within a proper way of dealing with all the dependency conflicts. It's pretty funny that I just went into Charles. I didn't know he was in the same panel with me. I ran into Charles and I said, okay, for the EIP, the Ethereum Improvement Forum, for the EIP forum, I've seen people asking questions about how parallel execution is not possible, how the people are complaining. But the problem is that nobody is able to come up with a solution other than the ETC forum. ETC forum has a project called Manis, and I was inspired from the Manis that a Scala-based project is able to resolve all the conflicts from the parallel execution of the contracts. That's why I told Charles that, okay, I want to impress him. And I said, okay, actually I know a project called Manis. And he said, oh, I'm the founder of Manis. He built Manis, but nobody else heard of Manis. That's the problem. So we lack of technical infrastructure, but we only care about the pump and dump. We care about the price of the quantum, price of Neo, Ethereum, EOS, but we can't ignore that. We lack of infrastructure that takes significant part in this business. So for sharding, it's the same. Zilliqa provides a sharding strategy that supports perfectly, I wouldn't say perfectly, flawless, not even flawless. Okay, I'm going to use flawless. So that solves the problem flawlessly on the transactions, UTXO-based transactions. But Zilliqa doesn't provide a solution for the contracts due to the dependency issues. That's why many people believe that Zilliqa is going to apply on the parallel execution on the contract. Still, they haven't come up with a strategy that can solve the key factor to this success, which is the dependency issues. The good thing is that I'm able to resolve that. Not 100%, but 95% of the chance I'm able to resolve this problem by sorting the problem out and address the problem into the address conflicts or the storage conflicts. For storage conflicts, there's nothing I can do, but for address conflicts, for example, like the transactions from exchanges, I'm able to resolve all these problems. And for sharding, it's the same. Sharding, the problem for sharding is that for contract sharding, you're facing the same problems. The dependencies. Let's say in one shard, in one partition, you want to unlock one of the account, and another partition, you're trying to make a transaction from that account because you don't know those shards, they work separately. There's no way you know that that account is unlocked or not. So that comes with the parallel execution problems. The good news is that we're facing this. So within like 1 year or two, people will be able to apply the parallel execution, which may increase the current Ethereum network from 20 TPS to up to 80 to 90 without sharding. And if we apply sharding on it, it can be easily go up to 2,000, which is the Visa's level. Visa handles 2,000 transactions per second. Not only for the, well, time flies. Not only for the parallel execution, we're facing optimization problems. The reason why I'm telling you this is that the Ethereum is storing all the balances, like I said, they're storing all the balances, they're storing all the data from the entire network, which makes data more than 1 TB. So which is really heavy for a full node. And a full node needs to modify within those 1 TB data. They find, okay, this account, I need to modify that account, I need to change the balance of this account, I need to unlock this account, I need to send transaction from this account to that account, I need to modify the balances. The problem is that the read and writes, we're experiencing bottlenecks for read and writes, and also we're experiencing bottlenecks on our storage problems. Currently, we know that we cannot make computers 100 times faster, especially for the SSDs. We did a great job in the SSD. Still, SSD is like 100 times slower than the memory. That's why LevelDB provides a way to read and write sequentially. I mean, sequentially read and writes 1,000 times faster than the normal way, the other relational database. Still, for random read and writes, which happens in the majority of the cases, we are still experiencing slope, the speed problems. One alternative way is to use caching method with the indexing theories. So we put indexes into the memory. The first time when we synchronize entire network like Ethereum or EOS, we put the indexing into the memory so we can minimize the read and writes to the hardware itself. That makes the optimization. There are a few projects who are currently focusing on this area, and we're lucky that we are able to adopt one or two, and we're going to evaluate all of them, their performance, and we'll be able to find out how we can leverage this utility into our public chain. But most importantly, for any public chain to build an ecosystem for developers, the data-friendly matters. The reason why Ethereum is getting so popular is that Ethereum is the easiest way for you to write your smart contract. You can learn smart contract within 30 minutes. It's easier as like a Tori language from Charles' Tori language. Solidity is so close to JavaScript. And for Ruff, we managed to reduce the barrier of the development by a large, significant amount. So here is an example of the coding. On the left side is a traditional old approach. I know many of you're not a programmer, but you can see that on the left side is embedded system development using C code. You have to know memory control, you have to know the process management, you have to know the coroutine. It's extremely hard for you to write coroutine within the C code. But on the right-hand side, you can see that everything is within the abstraction. We don't hear abstraction a lot, especially in blockchain, because people don't really care about that. But I think for any technology that needs to become mainstream, we're facing the abstraction. It's like mathematics, we're using abstraction with formulas and equations. And for your social network, we have to use the Facebook. Facebook is the abstraction. You interact as not only abstraction, but it's an interface. It's an abstraction and interface. You interact with your social network. And for blockchain, especially blockchain combining with IoT, Ruff built the abstraction. So our hierarchy is going to be like this. We have storage, fast storage that's cached, memory cached on the bottom, and we have consensus mechanisms. We have the good way of KV, MPT-based KV of our tree. And we have the contract, we have our partitions, we managed to use not too many shards, but we managed to use different districts, some sort of shards, but not too many. And we have a really user-friendly SDK for our application. So if you know how to write in JavaScript, you will be able to write any applications on Ruff. And that's the last thing I want to say is that definitely really matters. Remember when we have Android, remember when we have iOS, it makes the mobile development way easier than the old-fashioned WP methods. And we have a better user experience on that. So data friendly really is the key to success, although many people don't know that. The first few years are the years of the computer scientist, and the next few years will be years of the engineering, whether you like it or not. So be nice to the engineers just like me. So your future depends on us. Thank you.
Well, thank you, Ruff, for your